In AC circuits like loudspeaker systems, we use impedance, not just resistance, to describe opposition to current. It includes resistance, inductive reactance, and capacitive reactance. We use the symbol Z and measure it in ohms. Understanding impedance helps you safely connect multiple loudspeakers to an amplifier. Most AV loudspeakers have an impedance of 4, 8, or 16 ohms. Matching the total speaker load to the amplifier's rated impedance ensures safe and efficient operation. When loudspeakers are wired in series, the current flows through one speaker to the next. To calculate the total impedance, simply add the individual impedances. For example, two 4-ohm speakers wired in series would result in 8 ohms. In parallel wiring, each speaker connects directly to the amp's terminals. If all speakers have the same impedance, divide 1 by the number of speakers. If the values differ, use the reciprocal formula. Lower total impedance draws more current, so be careful not to overload the amplifier. A hybrid configuration combines series and parallel wiring. First, calculate the impedance of each group in series. Then treat those groups as parallel branches. While flexible, these setups are rare in fieldwork because they're harder to troubleshoot. Always measure total impedance with a meter before turning on the amplifier. This confirms your wiring matches the expected load. Testing helps avoid system damage or amplifier overload, especially when dealing with large speaker arrays. In large systems, transformers are used to adjust signal voltage for long-distance runs or for matching speaker loads. Depending on the windings ratio, they can isolate, step up, or step down voltage. Tabs on transformers let you select output levels. Be sure to use the correct one based on the design. If you found this video helpful, make sure to subscribe to the channel so you don't miss future episodes. And if there's a specific AV design topic you'd like us to cover, drop your suggestion in the comments below. We'd love to hear from you.